In question 6b then you're given this diagram here, which is a triangle and the incircle of that triangle, and you're asked to prove that this angle PQR, that is PQR, is equal to a half times CAB, which is this angle, plus CBA, which is this angle. In this question then you're going to need to know your theorems. In particular, I recommend looking at this one, Theorem 19, which states that the angle at the center of a circle standing on a given arc is twice the angle at any point of the circle standing on the same arc. So for example, in this question, if I draw these lines PO and OR, then they form the angle at the center of the circle, and that's going to be twice the angle that's formed by P, the circle, and R. So if I, for example, join P to this point and then join that to R, the angle that's formed by those lines is going to be half that of this angle here. To continue with that then, after I've drawn my new lines, I can say that this angle here, CPO, is 90 degrees because this side of the triangle forms a tangent to the circle, and my line PO is the radius. Secondly, I can say the same thing about this angle CRO, that's also 90 degrees, for exactly the same reasons. So I write that those two angles are equal to each other and equal to 90, because AC and BC are tangent to the radii. And that's just part of the definition of the incircle. Using that information then, I can say that this quadrilateral here, of course, the interior angles add up to 360, which is true for any quadrilateral, but if these two angles here, CPO and CRO, are 90 degrees each, then the other two angles must then add up to 180. So that just comes from the interior angles of a quadrilateral being 360. As I mentioned in the hint though, I know this angle here, POR, is twice the angle that's right here, PQR, just by Theorem 19, that the angle at the center of a circle is twice that of the angle at the circumference of the circle standing on the same arc. So I know that POR is equal to twice PQR, so I can replace POR in this statement with twice PQR. So ACB plus twice PQR is equal to 180 degrees. On a side note, I know that these three angles here, the vertices of the triangle, all add up to 180 degrees. That's the interior angles of a triangle add up to 180 degrees, and that's also known as Theorem 4. I know then, because these two statements are both equal to 180 degrees, they must then be equal to each other. So that's what this statement is here. Notice that ACB is in both of these statements, so I can cancel that out. So now I have this statement here, and if I divide everything by 2, I get PQR is equal to a half times the angle CAB plus CBA. And if you go back to the start of the question, you see that's exactly what we were asked to prove right there.